To edit the temperature, firstly, identify the system or device you need to adjust. This could be a thermostat controlling your home's heating or cooling system, a temperature controller in an industrial process, or even a setting in a software application. Secondly, locate the interface for temperature adjustment. For a physical thermostat, this typically involves buttons, a dial, or a touchscreen. For software, look for settings menus or control panels. Thirdly, understand the current temperature and desired temperature. Knowing the starting point and your goal is crucial for making informed adjustments. Fourthly, make the necessary adjustments using the provided controls. On a thermostat, you might press the up or down buttons to increase or decrease the set point temperature. In software, you might type in a specific value or use sliders to modify the temperature. Fifthly, confirm the changes. After making the adjustments, ensure that the new settings are saved or applied. Some systems require you to press an OK or Apply button. Sixthly, monitor the system's response. Observe whether the temperature begins to change in the direction you intended. It might take some time for the system to reach the new set point. Seventhly, fine-tune as needed. If the temperature doesn't reach your desired level, make small adjustments and continue monitoring. This iterative process helps you achieve precise control. Eighthly, consult the device's documentation. If you're unsure about any of the steps or controls, refer to the user manual or online help resources. These documents often provide detailed explanations and troubleshooting tips. Ninthly, consider safety precautions. When working with temperature-sensitive equipment, be aware of potential hazards such as burns or equipment damage. Always follow safety guidelines and wear appropriate protective gear. Tenthly, understand the units of measurement. Temperature is commonly expressed in degrees Celsius or Fahrenheit. Ensure that you are using the correct units for your application. 11thly, be mindful of energy consumption. Adjusting the temperature can affect energy usage. Optimize settings to balance comfort and efficiency. 12thly, check for overrides or schedules. Some systems have pre-programmed schedules or override features that can affect temperature settings. Make sure these are configured correctly to avoid unexpected changes. 13thly, consider external factors. Ambient temperature, weather conditions, and other environmental factors can influence the performance of temperature control systems. Take these factors into account when making adjustments. 14thly, document your changes. If you're working with complex systems, it's helpful to keep a record of the temperature settings and adjustments you've made. This can aid in troubleshooting and optimization. 15thly, use calibration tools if necessary. For critical applications, it may be necessary to calibrate temperature sensors and controllers to ensure accuracy. This involves comparing the readings to a known standard and making adjustments as needed. 16thly, be aware of hysteresis. Hysteresis is the difference between the temperature at which a system turns on and the temperature at which it turns off. Understanding hysteresis can help you avoid oscillations and maintain stable temperature control. 17thly, implement feedback control. Feedback control systems use sensors to measure the actual temperature and adjust the control output to maintain the desired set point. This provides more precise and stable temperature control. 18thly, consider using PID controllers. Proportional integral derivative controllers are a type of feedback controller that can be tuned to optimize performance. They are commonly used in industrial processes and other applications where precise temperature control is required. 19thly, monitor for alarms and alerts. Many temperature control systems have built-in alarms that trigger when the temperature exceeds or falls below certain limits. These alarms can help you detect problems and prevent equipment damage. 20thly, use data logging. Data logging systems record temperature readings over time, allowing you to analyze trends and identify potential issues. This can be useful for optimizing performance and troubleshooting problems. 21st, understand the limitations of the system. Every temperature control system has limitations in terms of accuracy, range, and response time. Be aware of these limitations when making adjustments and interpreting results. 22nd, be familiar with common troubleshooting techniques. If you encounter problems with a temperature control system, there are several troubleshooting techniques you can use to diagnose the issue. These include checking the power supply, sensors, wiring, and control components. 23rd, use appropriate tools and equipment. When working with temperature control systems, it's important to use the right tools and equipment. This includes multimeters, thermometers, and calibration devices. 24th, be aware of safety regulations. Temperature control systems can pose safety hazards if they are not properly installed and maintained. Be sure to comply with all applicable safety regulations and guidelines. 25th, seek professional assistance if needed. If you're unsure about any of the steps involved in editing the temperature, or if you encounter problems that you can't resolve yourself, seek professional assistance from a qualified technician.